Yeah, some of you might have already seen me before, like Alex. Welcome to your second session, your subject option explain. So we have a bunch of subject coordinators coming out. They're going to spend around 3 to 5 minutes explaining their subjects. So we're going to start off with biology.
Okay, welcome everyone, and congratulations on obtaining a place at Australia's top university. I'm Dawn Gleeson, and I'm just going to tell you very briefly about biology, which is the study of diversity. Just have a look at these slides here. Look at the diverse range of organisms. These are some of the things we're going to look at in first year biology. But these organisms have a lot in common, and many of them share very similar genetic codes. So in biology, we're going to look at the diversity of life and the continuity or the similarities between organisms. And they also share biochemical reactions. This is the first module test. You need to memorise that. Joking. Okay, so in biology, what do? Well, there's a lot more than learning about life. We teach you other skills, and this is relevant to all of the subjects about which you're going to hear today. We teach you how to work in a group, how to communicate, both verbally, written, and visually. We have things like problem-solving skills that we improve. But apart from that, we teach you how to use appropriate laboratory equipment and how to come to terms with the basic knowledge in biology. Now, some of you might be sitting there and thinking, gee, that sounds great. Can I do biology? I didn't do it at year 12. Yes, you can. Biology does not have a prerequisite other than that you're a member of the Faculty of Science and enrolled in the BSc, and you can study it as breadth if anybody is in another faculty and coming along for interest. So, no prerequisite for biology. You can find out about the subjects by going to the expo table. I won't go into detail about those. And by studying biology, you're underpinning a number of majors within the BSc. And this is just a list of some of them there. And you can also have subjects that complement each other. Maybe you're thinking of a job in bioinformatics, so doing some IT, some mathematics and some biology will equip you for that. Perhaps you're interested in genetic counselling, so doing some psychology with your biology and so on. So don't just think of subjects on their own, think about complementary subjects that may lead you to a variety of different options as in your employment. So that's it from me. We look forward to seeing you in first year biology. And now I'm going to hand over to Nick, who's going to talk to you about IT. Don't forget, let's go.
Hi everyone, welcome from the natural world to the artificial world. So we're talking a little bit about information technology. First up, quick quiz. Who's used a computer today? Hands up. Yeah, so I pretty much expect to see everybody's hands at the moment because the fact is that computers are ubiquitous in this day and age. The most recent revolutions, the information revolution, has changed the way that so many different facets of our world operate today. The way that we shop, the way that we travel, the way that we interact with one another, the way that business is conducted, the way that research is carried out in a whole range of different domains. All of these things have been transformed by computers. And what computing is, so what computing isn't to start with. It's not about fixing printers, it's not about just writing a web page or something. Computing is fundamentally about teaching you how to communicate with computers in a way that enables them to do things for you, to do really cool things that we couldn't do by ourselves. And much of computing today is about processing information. It's about taking the masses of data that we can collect from the world, about collecting it, about managing it, about translating it into useful information and learning really cool stuff from it. And the way way in which we do this is by learning how to talk to computers by writing programming languages. And that's what we're going to teach you in first year computing. Computing brings in lots of different types of skills and ways of thinking about the world. If you're into sort of engineering and computing involves building large systems. If you're into sort of analyzing data, it brings in maths and statistics. If you're interested in psychology, it brings in ways of thinking about how humans solve problems so that we can try and use that to build computers that are able to solve problems for us. Machine learning and artificial intelligence are huge areas at the moment. It's a highly marketable skill. If you look at some of the largest companies in the world today, they are technology companies, and a whole diverse range of different companies are looking for people who can bring the computing, the technical skills to be able to work with and manage and capitalize on their data. So it's highly employable. Even if you don't go on to study computing, doing a couple of computing subjects in first year can be really useful. It teaches you a very different way of approaching problem solving, of formalizing a problem, and solving it in a very rigorous fashion. So it's a useful skill to have under your belt, both in terms of the technical skills, but also the conceptual skills. Okay, again, there are no prerequisites for going into computing. Some people will go in having programmed a little bit before. Even if you've never programmed before, our first semester subject is designed with that assumption in mind and to teach you from the get-go how to learn about programming. It's quite a fun subject. And there are, if you do stick with computing, and our first year subject does convert a lot of people who weren't previously thinking about computing to wanting to stay with computing, there are a huge range of different options that you can follow in later on in your degree, all the way from graphics, from human-computer interaction, through to artificial intelligence, machine learning, working with big data, lots and lots of different options. There are only 2 first-year computing subjects, so it's a very easy decision to take. They're very easy to blend in and to complement with other degrees. So we hope to see lots of you either this afternoon to answer any questions you may have, or later on down the track. Thank you very much.
Thank you. My name's Sonia, and I'm here to tell you all about chemistry. I am the first year coordinator, so you and I are going to build up a wonderful relationship over the next 12 weeks. You'll be sick of me by the end of 12 weeks, but that's all good. Alright, enough about me, let's talk about you and what chemistry is. Now you're going to hear a lot of us get up here today and talk about solving problems. We all want to solve problems, all these big global issues around the world, we all want to solve them. And the way that chemistry solves these issues, and I'm going to make sure I can use this. Oh no, I just turned it off. Computer guy, can you show me the laser pointer? Is this a laser pointer or is it just a clicker? I think it's just a clicker. Anyway, it's just a clicker. I can't point. Anyway, we're going to answer questions. Chemistry answers questions. We try to solve all these big global issues by looking at coming down to that molecular level, right? Coming down to those fundamental little building blocks we know as atoms, right? Looking at how atoms and what they do. And as chemists, we like to answer the question why. Why things happen, right? For example, if you look at that, those 2 pink little vials, and in front of that pink little vial, you'll see some gold ingots there. There's some just from my personal collection. That's how much they pay me here. They pay me in gold ingots. No, they don't. Not far from it. No. Anyway, back on track. We know they're gold, right? We can tell they're gold by looking at the colour of them. Yeah, the colour, that bright, shiny, metallic yellow colour, we know that's gold, right? But if I was to take one of just a tiny little bit of that gold and ground it down to tiny little particles and put it into a solution, it's no longer that beautiful, shiny, yellow, metallic colour anymore. It turns into that pink colour. Why? As chemists, we can explain why that happens, right? But as chemists, we also like to solve, I said we like to solve big global issues. If we move down to the picture underneath that, there's this big molecule there. Environmental issues, we try and get involved in that. That molecule there was designed to capture excess CO2 in the atmosphere. Right? We know carbon dioxide in the atmosphere is causing a big problem. We're producing way too much carbon dioxide, we're chopping down trees, we can't get rid of the carbon dioxide. This is causing atmospheric climate issues, oceans are becoming more and more acidic, a lot of environmental issues. That's there designed to remove that carbon dioxide from the atmosphere. If we move up and to that one where we've got that big polymer that's being bent, right? Sustainability, we're looking at developing plastics that are more biodegradable, reusable. That there, in fact, is a polymer that is being designed. It's for your mobile. It's not a big global issue, but mobile phones, right? Mobile phones you put in your pocket, you sit down, oh, my screen's cracked. Yeah, you can't bend a mobile phone, can you? But with new screens, we may be able to, right? These are what chemists do. It's not quite that, moving across to the right. There's a drug there, a pharmaceutical. Chemists get involved in designing new drugs, and in fact, about a month ago, you would have heard in the news, motor neuron disease, a new drug was designed, and it's been shown to slow down the effects of motor neuron disease. Yeah, you would have heard that, yeah? That was designed here at the University of Melbourne by one of our chemists here, right? Yeah, awesome. You all want to be a doctor? Doctors might help a couple of thousand patients a year. Design a drug, you can help millions, right? And as chemists, that's what we can do. More environmental issues. That last one there in the bottom left-hand corner, that there is a solar panel, right? Some of you may have big solar panels on your roof to convert that solar energy to electrical energy. They're big, they're ugly, they don't convert a lot of that solar energy to electrical energy. Why can't we make that solar panel, design a solar panel that's smaller and more efficient at converting that solar energy to electrical energy? That's just some of the things we do as chemists. I won't show you that video because I'm running out of time. We'll just go over. And what you're also going to see is that a lot of these disciplines, science disciplines, actually complement each other. And I know Dawn spoke about that a little bit earlier. Without understanding physiology and biology, we can't design new drugs, right? Without understanding physics, we can't create better solar panels. So all of these disciplines actually really do complement each other. My best advice to you over your next 3 years here is to follow your passion. Do what you want to do. Right? If you pick subjects that you love and enjoy, you will become a successful scientist. That's all I think I have to say. If you want any advice about what, we've got different chemistry subjects available at first year level. If you want advice on which one to do, please come see me at the Science Expo later this afternoon. Thank you. And now
welcome to the University of Melbourne. My name's Anne-Marie. I'm a paleontologist at the School of Earth Sciences, and this is where a whole world of opportunity awaits you. When I was growing up, I loved David Attenborough, and I really, really wanted to travel. And I've been fortunate enough to sort of come into earth science quite accidentally. I was really interested in biology, but I followed into paleontology, and I have managed to go on conferences or field trips to all of the 7 continents. And it is a really fantastic way for you to get a career that is exciting and diverse and really loads of travel as well. So you can see that our teachers, our lecturers and academic researchers, as well as our students, get to go right around the world doing really interesting stuff. You might combine with chemistry to look at the pollutants in the oceans, or study the atmospheric physical dynamics, or look at the origins of mountains like the Himalayas that are still growing. Looking at plate tectonics, or the oldest diamonds in the world, for example, or I was fortunate to go and collect a fossil of huge forest, of a plant that was forming huge forests right across Antarctica only 50 million years ago. It is a very long time in human terms, but in terms of the Earth's history, we can study this most recent greenhouse climate and learn about what is going to happen in the future. So, if you like an exciting, diverse career, it is really transferable overseas as well. So it's a great way to travel. If you're interested in climate change, this is where we study the atmospheric processes. And if you're more interested in those topics you looked at in disasters earlier today, this is where we also look at earthquakes and volcanoes. And if you like to combine them, we also offer majors in environmental science. So we're solving those issues by using a combination of the different sciences. And we're looking at how the Earth works, whether it's cyclones and storms and oceans, or more of the geology. It can lead to jobs. All of our graduates get jobs, and diverse things like geotechnical engineering and environmental science consulting is taking up graduates and offering them extremely good graduate salaries. So that's certainly something to think about when you're doing your undergraduate. Where are you heading? And this is a great way to get into career. We also offer field trips. This is the only first year subject in semester 2, in fact, that offers you a field trip out of the university. We go down to the coast, along the beach for a few days, and we study the world that we live on, the Earth. Everybody lives here. This is a great way for you to learn more about our own planet. And as I said, combined with a lot of the other sciences, hopefully maybe one day you'll end up with NASA.
I have a very difficult job to do. So most of you guys at high school have done physics, chemistry, maths, maybe some of you psychology. None of you have done engineering. So I have 3 minutes to tell you all about engineering and to get you excited into engineering. It's not possible, so I'm not going to do it. The word engineer comes from Latin. I had to go through Latin as a high school student. And if you believe me, it comes from the Latin word ingenium, which refers to one's native genius to design or create things. I think this is a great indicator that if you want to be an engineer, you're going to be a genius, and if you're a genius, you're going to be an engineer. It's a clear connection between the two. So, as I said, it's an impossible task, so I've put a quote of a famous guy up there called Theodore Moncohen. His picture's in black and white, so he must be famous, he must be full of knowledge. He says, scientists study the world as it is, but engineers create the world that never has been. And that's what underpins engineering. Okay, it's creativity, it's design. Now, use this quickly, yeah. So there's a more official definition of engineering. Too long don't read. Pick out the green words there. It's a profession. We apply judgment to things, but more importantly, we do it for the benefit of humanity. We do stuff that makes people's lives better. But we also set ourselves aside a little bit in that we typically work in large teams and we work on very complicated problems, okay, that need creativity, need ingenuity in order to solve them. So, for instance, you might not be thinking about engineering, but who here had breakfast cereal in the morning today? Did anyone eat breakfast cereal? It's really not popular these days, but if you had breakfast cereal, yeah, I'm going to pick another example. Obviously, there's a big chain of process involved in creating that and delivering it to your table. And part of the process would be a tractor. Mechanical engineers design the tractor, or at least the combustion side of it and everything. There are chemical engineers that do the process equipment that processes the grains, etc. Right? Mobile phones, that's an obvious one. Base stations, that's telecommunications. Signal processing, electrical engineer, computer engineering. Wow, there's a big field out there. Even monkey bars, right? They make people's lives better, don't they? Yeah, and a civil engineer or mechanical engineer had to do the calculations to sign off on that to make sure, 10 kids get on there and the thing doesn't collapse. Okay, we make other things, electronic things, that's obviously engineering. But one of the really interesting areas of engineering that's taking off is biomedical engineering. So this is infusing mechanical, electrical bits and pieces into people and making their lives better. One of the big developments in this area, the bionic eye, was developed right here at Uni Melbourne. So good on us for doing that. All right, we also do crazy stuff like cooking fish. That's about ingenuity, right? Where do you get from our engineering subject? So I said I wasn't going to tell you about engineering. I did a little bit, but we want you to discover what engineering is by taking one or two of our first year subjects. Okay? All we ask is you be in the Bachelor of Science or have Year 12 maths, a certain level of maths, and that's it. We don't care. We have no standards and we don't discriminate against anyone. Come on in and try us. You'll like engineering after doing those subjects, and this is where you will end up, somewhere in one of these wonderful places. Okay, I will now pass you across to Elaine. Oh, it's over here.
Hi everyone, very warm welcome to the University of Melbourne. So I'm Ilan Wiesel from Geography. I'll tell you what is geography and we'll try to convince you how interesting and wonderful it is. So most of you have done geography quizzes and you've heard questions like what is the capital city of Australia and other things. Geography is actually much more than that. It's really about the interaction between natural systems, the environment, and also human society cultures. And that's what we do as geographers. We're trying to understand natural science, but we also try to understand the human systems behind and how those two interact. And we believe that to solve those big problems of our world, and we've talked about some of those today, climate change, famines, outbreaks of viruses, all those things involve both an understanding of the science behind it, but also aspects such as policy, such as culture, and human factors. So in geography, we have human geography, which involves scientific exploration of human society, human culture, human politics, as well as the physical geography, which looks at the natural sciences of the atmosphere, the geosphere, the biosphere. So we work together with biologists, chemists, earth science, IT, maths and stats, but also with psychology, sociology, cultural science. And we work together, and in geography we also teach together and do research together. So many of our subjects will involve, for example, we have a subject about disaster resilient cities. So that would involve understanding from physical geographies what's an earthquake and how it works in terms of the physical earthquake, but also understanding why is it that in some natural disasters more women die, or why is it that a particular social group is more vulnerable to disasters. So seeing those kind of human and natural dimensions of disasters. And it is about sort of real world problem. We go out to the field, we try to understand things like climate change, like famine. We go to those places where those things are happening all around the world. Subjects all involve fields, field work, field travel, and we do have subjects that are primarily field-based. So we go to Tasmania, to New Zealand, to Arnhem Land, and other places. To study geography, we believe that to understand those things, you have to step out of the laboratory and see things in their natural context. So if you want to be an innovative scientist, you want to have an impact on the world and actually influence policymakers, decision makers, and culture itself. And if you also want to have fun and have the real time of your life traveling, we welcome you to geography. Come visit us at our geography desk today at the Expo, and we'll tell you all about it. Thanks.
Okay, so maths and stats. So I want to start by saying I completely agree with what Sonia from chemistry said today. Completely agree with her. You should major in chemistry. I don't mean that. But what I completely agree with her about is you should follow your passions. When you get to university, you might find that the things that you really enjoy and find fascinating are not necessarily the things that you enjoy so much at school. If you're a person who likes generalisations, you might find that you really enjoy studying mathematics. My favourite example here, how do we figure out how many colours we need to colour the map of Australia so that we don't have the same colour on either side of the border? How do we figure out how to put a bunch of students into lectures so they don't have any clashes? They look like completely different problems, but the mathematical analysis, when you boil it down, is the same. It's all about the same sort of mathematical problem. The more maths you do, the more interesting the applications get. The things that you did in your high school maths, the kind of applications you could tackle were a bit limited by the kind of things the kind of mathematical techniques you knew about. As you go further on in applied maths, it's more and more interesting. And you can go deeper. So everyone knows, right, what's meant by a differentiable function. You're all science students, you know about that. You know, it's a nice smooth function. Look, the graph looks nice and smooth. But what about a function that goes crazy near zero, like this one? Bounces up and down like crazy near zero. Is it differentiable at zero? Well, there you have to go deeper. You have to start thinking more carefully about what it means and really going down to the definition and learning a bit more about it. And there are some surprises there. I'm not going to tell you the answer, but by the time that you've finished the main first year set of subjects, calculus 2 and linear algebra, actually should know how to solve that problem, at least to a reasonable extent. And then in second year, you go even deeper into the same topic to understand it. So, that's kind of, again, if you're that kind of person that wants to go a bit more deeply into these kind of ideas, think about taking maths. So, maybe I should just say briefly what kind of areas, if you do decide to major in maths, what kind of areas you specialise in. I think pure maths and applied maths, sort of everyone understands. Discrete maths and operations research, this is about the kind of mathematical techniques that are used to analyse problems in industry and society. How do we make a public transport system run efficiently? How do we make production in a factory run efficiently? All of those kinds of techniques, all those kinds of issues. Stochastics, statistics, you know about that. That's about how do we analyse causality in a world where there are all sorts of random influences. Stochastic processes is sort of about going back the other way. How do we build randomness into models? And of course, you might also want to do one of our cross-disciplinary majors. So our cross-disciplinary major is computational biology, about dealing with massive amounts of computation that are now required to solve problems in analysing the data that's coming out of genetics. Data science, I'll talk a little bit more about in a minute. Mathematical physics, I guess you know that maths and physics are very inextricably linked, and so we have a cross-disciplinary major there. Okay, don't take my word for it. This is the Harvard Business Review. I'm not a data scientist, right? Of course. So, I don't want you to make a logical, fall into a logical fallacy here. Just because I'm not a data scientist, you can't conclude anything. But this is really about big data, about how do we cope with, how do we analyse, how do we get useful information about the huge volumes of data that are now emerging in the modern world. This is a cross-disciplinary one we do with maths and statistics and computer science. So those are the kind of things we do in maths and stats. If you don't decide to major in maths and stats, having some maths and stats in your degree, having relevant stuff in your degree, in your toolkit, is an excellent complement to many, many other areas of science, and indeed many areas of outside science, economics and so. Finally, I just wanted to say, it's not always obvious where the career paths are for someone in mathematics. You'll see lots of job ads that say statistician. You rarely see a job ad with mathematics in the title. But there are a lot of opportunities out there. The Australian Mathematical Sciences Institute produces this great booklet, Careers Guide, for Maths and Stats graduates, and it's got, amongst other things, heaps and heaps of job ads in it. Yeah. And they're all job ads where the employer is looking for someone with a maths or stats background. So you might see something advertised for senior quantitative analyst, a whole range of things. A whole range of titles that don't include the word mathematics, don't include the word statistics, but what they're looking for is someone with a maths or stats background. If you're interested in this, I'm hoping we'll have some copies of this available for you on the table this afternoon at the Subject Expo, but if not, we'll give you a little postcard that shows you where to get one. I think that's about all I wanted to say, and I'll hand you over to Cindy now.
Can you hear me? Excellent. Okay, welcome. So great to see so many of you. My name is Jacinta. I'm coordinator of the first year physics program here, so I'm hoping to see many of you in the classes in the labs. Where am I going here? Okay, who's thinking of a major in physics? Few hands. Excellent, excellent. Who has to do physics because they're doing engineering or veterinary science? Okay, yes, that's generally the look that we get. I want to hopefully convince you that you're doing the right thing. Okay, there's a reason for this. Who's not doing physics? Okay, all right, and that's fine. You're perfectly allowed to choose whatever subject you want to do. My job at the moment is to convince you, because you know you've got those extra subjects that you're trying to choose at the moment, okay? You don't know what to pick. You've seen all these people talk about these amazing subjects, and now your mind's blown because there's too many to choose from. So I want to just demonstrate to you what we do here at the University of Melbourne and how physics combines with maybe some of the subjects that you're planning on doing, but maybe haven't thought about doing physics, or maybe the other way around. Maybe you're going to do a major in physics, but you may not have thought about linking it with biology. Biology and physics. Okay, so let's see. We all love money. Yes, don't tell me you don't. Okay, and we don't like it when people copy our money because that's forgery and that's bad. Okay, so one of our projects has been working with the Mint, the Australian Mint, to protect our money so that people can't steal it from us or Big data. We've heard about big data. Physicists are really into big data because we have experiments, really big experiments that create a lot of data, like astronomy and particle physics. So we need to know about this. Climate change, energy. We all want to do something about that. 302 is a very special program or project here at Melbourne University. It's a bit of engineering, a bit of medicine, and a lot of physics. And they're designing a process and equipment that creates oxygen without electricity, so not using electricity, to give babies who are dying of pneumonia out in the remote villages of Africa and saving these babies. Bionic eye, you heard about that. Physics was involved in that as well, okay? Very cool stuff. I mean, this is diamonds in your eye, literally. Nano MRI. So physicists have been involved with the MRI equipment, machine. But now we've created this nano MRI that uses quantum mechanics, quantum physics, to image really, really tiny things, and the outcome of that is creating new drugs. Skyhopper. Us physicists, we're happy on Earth, but we like to get up into space as well. So you could get involved in designing a spacecraft that looks for new planets and so on. This one in particular is going to be a nano spacecraft, and it's about as big as a shoebox. Very cool. And quantum computing. Like, this was something 5 years ago that was sci-fi. It was, scientific fantasy. And now it's real. And we've got IBM actually situated in the department now, working on supercomputing, and you can actually do subjects down the track, not the first year, down the track where you can actually program a supercomputer or a quantum computer. Okay. So, and they're just a few of the projects that we have going on in the School of Physics. So that gives you an idea of how all these things interrelate, and hopefully you'll go away and come back and talk to us this afternoon about how you can combine the subjects that you've chosen and the subjects you're looking at choosing, and maybe study some physics. Just to finish up, physics is about knowledge and imagination, okay? It's not just about giving you information. That maybe is where you're at the moment. You've learned, you're beginning to understand things. We want to take that further. We want to show you, we want you to be able to show and apply the physics, and then take it even further when we get into these amazing programs and projects and create and, take it to the next level. And I'm going to leave it there, and I'm going to pass you over to last but not least. We leave the best for last every time.
Yes, as you notice, all of my colleagues have gone except Jacinta. It's because when psychology comes up, they just cry because we're so good. We're so fascinating. Everyone's naturally fascinated with us. That, by the way, is not me, that's Charlotte, who used to work in the department. Still has her picture on several things. She's somewhere else. One thing that it works every time. I work in vision science, and she will do first year psych, which of course you'll get the sensation of perception. And demos that work are things that we like. I like them. This is one that always works, and also you still remember it. This was from a few years ago now, and yet, how many of you have not seen this before today? I apologise for showing you that. It's like taking your virginity away. So, the dress is this picture that someone accidentally put on Instagram, I believe, and started this huge argument about whether it was white and gold or black and blue. And on Twitter, everyone was arguing about it for about 24 hours. I heard about it from my PhD student with a text at 8 in the morning saying, what colour do you think this dress is? I have 25 first years who want to know, and that made me ask, why are you shopping with 25 first years? Because I haven't seen anything about it. And why do you want to buy such a repulsive dress? I found out what it was and ended up on the radio 4 or 5 times that day. People asking me, yes, if I see white and gold, does it mean that I'm this kind of person and I'm cleverer than people who see black and blue? No, it doesn't. But the interesting thing about this is we are fascinated by the fact that we all see a slightly different world. And we rarely really think about it until something like this comes up, when you can actually have an argument with somebody, or a discussion with somebody about seeing a demonstrably different version of the world. So one of you will see white and gold, one of you will see blue and black, and then some of you will see in between. And it was complete coincidence it came up. It works really well, and people have been desperate to try and replicate the dress as an effect since then, because it got so much attention. So we do care about how we see. And from the point of view of a vision scientist, we don't have the answer to this either. We don't know why it caused such disagreement. We have ideas about why the disagreement was so extreme, but we don't know the answer. There's so much we don't know about basic functioning of the brain, including those very early bits constructing the reality that you experience, that everything afterwards is fascinating. And one of the things that, I've been doing this for 15, 16 years, if not longer, one of the things that I've always noticed that when people come in to do psych, even if you've done VCE psych, which is a relatively new thing actually, you're never quite sure what a psychologist is, or rather what psychology is. And that's because it's an enormously broad discipline. If you do psych, you'll start off learning about neurons, how neurons connect to one another, then you'll learn about how we use the output of those neurons to construct the reality that you experience, how we use that reality to learn to deal with the world and interact with it and each other, how that changes over the period of your life, how that forms your personality, what happens when it doesn't go so well, and we end up with different versions of the world which can be distressing, and why and how we work as groups in the way that we do. That's all psychology. Fundamentally, it's all about us, about people, and why we interact in the way that we do and why we are the way we are. And we love that because we are fascinated by ourselves, sometimes in a narcissistic, unpleasant way, other times just because we are interested in finding out more, and we're fascinated with the way our brain works, and we have this little lab in our head that we can play with all the time. One of the things that, I suppose is a moderately recent thing for me is to examine how this changes over a period of time. And this has happened to everybody. You were born and you were basically helpless. You were popped out and then someone started looking after you. You managed to move your arms around, you sort of opened your eyes, you started to see the world, you started to hear the world, you recognised your primary caregivers, the people who were important to you through various senses. Then you started to be able to control bits of you. After a while you could start to move around. So the brain, the thing that was controlling this body that you've got, actually could move around its environment. That completely changes the rules on which the brain's working and has to deal with its world. So it starts to crawl around. Then it learns how to balance, walk. Then it will learn how to do things like dance to Amyl and Sniffers, if I can get him to work. This is Gulliver the suit, actually. This is about a year ago. He's dancing to Amyl and Sniffers, and then, exactly like Gulliver, he notices I have my phone. And he is completely obsessed with it, like all of you. That never goes away. Although I have to say, he's somewhat less obsessed with it now than he was then. Psychology is about how we become who we are, how we can possibly get to where we might be, right from the very beginnings to when we're no longer around. And how, during that period of time, we impact everyone and everything around us. And consequently, it's just inherently fascinating to do. I love talking about it, as you can tell. We're here for another half hour, so and it never bores me. It's something, and I don't have a particularly long attention span. It's not like it's difficult to bore me. I'm quite easily bored, actually. Psychology and talking about this stuff never bores me. And one of the things that I always I'm incredibly interested in what's happening now, but also what happened a long time ago. Because one of the things that shows a beautiful progression of thought throughout history is how we thought about ourselves in psychology. And this quote by William James, who is someone who I have regular respect for and writes beautifully, which is sadly lacking in science these days. I use this quote a lot, both in my lectures and in my own work, to remind me what I'm interested in, where I'm going, because that particular quote there, I think, encapsulates the basic reason why we're so fascinated in everything about it. Why do all of these things cling in the way that they do to produce whatever it is that we're experiencing at the moment? You will hopefully experience more of that. I hope you have a fantastic year and just enjoy yourselves, because if you don't enjoy yourselves, you won't learn anything. Thank you.